Now I am going to talk about fourth order Runge Kutta method. Fourth order Runge Kutta method is given by the formula K1. K1 is f of xn yn. K2 hf of xn h by 2 yn k1 by 2. K3 hf of xn h by 2 yn plus k2 by 2. And K4 hf of xn plus h yn plus k3. Now yn plus 1 is yn plus k1 plus 2k2 plus 2k3 plus k4. So here k1, k2, k3, k4 are slope of the OD at different points. Now we have to calculate k1, k2, k3, k4, and finally we have to take the average and then we add with yn. Now here I am taking one example. So this is first order OD. Dy by dx is equal to x square plus y, where at x is equal to 0, y of 0 is 1, means at x is equal to 0, y will be 1. Using fourth order Runge Kutta method, approximate the solution of the OD and find y at x is equal to 0.1. Means one step we have to do the calculation. If we know how to do the calculation, we can do any step. Now let's divide the interval 0 and x into smaller sub-interval with a step size h. The nth point is denoted as xn is equal to x0 nh. x0 is equal to 0 is the initial point. The fourth, the Runge Kutta method involves the following calculation. We already know k1 is h of f of xn yn, k2 h into f of xn plus h by 2 yn plus k1 by 2, and k3 h into f of xn plus h by 2 yn plus k2 by 2, and k4 h into f of xn plus h yn plus k3, and yn plus 1, that will be yn plus k1 plus 2k2 plus 2k3 plus k4 by 6. Now let compute the numerical approximation of the solution using fourth order Runge Kutta method for x is equal to 0.1 and step size h is equal to 0.1. Now we are going to calculate k1, k2, k3 and k4. Now y0 is equal to 1 at x0 is equal to 0. Now using Runge Kutta method, first we have to calculate k1. k1 is h f x0 y0. So h is 0.1 and f of x y, so that is x square plus y. Now here x0 is 0 and y0 is 1. So after doing the calculation, that will be 0.1. Similarly k2 f h into f x0 plus h by 2 y0 plus k1 by 2. So x0 is 0, h is 0.1, h is 0.1 by 2, and then okay, so that will be x0 plus 0.1 by 2 the whole square, and then y0 is 1 and k1 is 0.1 and 2. Okay, in that bracket, so that is the formula. This is x square and this is y. So after doing the calculation, we will get k2 is 0.105. Similarly k3 h f of x0 plus h by 2 y0 k2 by 2. So x0 h by 2 already we know. Okay, so 0 plus 0.1 by 2, and y0 plus k2 by 2 1 plus 0.105 by 2, and we have to put in that formula. So 0.1 into f of this is that x square plus y. So after doing the calculation, we will get 0.11025, and k4 h into f of x0 plus h y0 plus k3. So h is 0.1 and f of x0 plus h is 0 plus 0.1, y0 plus k3. So y0 is 1 and plus this, and that will go to this formula, so that will directly here. So 0.1 plus x square plus y, so that will give 0.112. After getting all these k1, k2, k3, k4, then we have to calculate that y1. y1 is y0 plus k1 plus 2k2 plus 2k3 plus k4 by 6. Now here plugging all this value. So y0 is 1, k1 is 0.1, k2 is 0.105 into 2, 2k3 is 2 into 0.11025, k4 is 0.112 by 6. After doing that, we can get 1.055. Similarly, we can do x is equal to 2 with, means here x is equal to 1 with step size 0.1, we are getting 1 point, that is 1.055. This is the calculation. Now you can do any step. Okay, similar procedure. Now here after doing the calculation, so initially x is equal to 0, y is equal to 1. After doing the calculation, x is equal to 0.1, y is equal to 1.055. Now you can take anything, you can get y value. So that is about Runge Kutta fourth order method. That's it for RK4 method.